Cloud and Clear, the podcast by SADA for innovative business leaders and technology enthusiasts, where we explore how Google Cloud is transforming the industry and what that means to you. Now here's your host, Tony Safoian.
Ryan Damm, CEO of Visby.
Tony, thank you.
Welcome to Cloud and Clear.
Cloud and Clear.
Super excited to meet you in your offices in San Francisco. And I'd love to get into what Visby's doing, but I think to create the appropriate context, I want to know more about Ryan Damm, the man.
Not a lot to know.
I think all of our experiences kind of bring us to where we are today, and I think what you're doing with Visby is super interesting, and it's a completely new realm that I didn't really know existed until I was preparing for this. But I'd love to know, your background, your experience. I was reading the profile, just super fascinated, obviously way above my sort of experience and realm and possibly IQ, but I'd love to hear about how you got here.
Yeah, I mean, I'm just kind of a classic camera geek, camera nerd, but I've been playing around with kind of fun optical stuff for pretty much my entire career. That's kind of the through line. I was playing around with big camera arrays to do bullet time back in the early 2000s. Was prototyping my own camera gear.
Bullet time.
Yeah, so you put a lot of cameras in a row, and then you kind of take frames from each camera successfully, like the Matrix shot,
The
where you'd be
Matrix
falling
shot,
out. Yeah.
of course.
So I was super low budget indie, was wiring together these disposable digital cameras, and farting around with that 20 years ago, which is now I've got bigger arrays of cameras, so it's sort of closed loop. But I've always been a big hardware nerd, and was fabricating lenses and playing around with optics while kind of shooting commercials and just being an indie video guy.
Have you always been in San Francisco?
Pretty much, yeah.
Oh, cool.
Yeah. So then I got into the startup scene. Actually, a open access prototyping lab hired me because I was making optics there, and they just kind of pulled me in-house. And that got me into working at startups. And then I shot a commercial for a startup in the fitness space, and that led to like a 10-year digression of filming trail runs and trail rides and stuff, literally running down mountains with big digital cinema cameras.
When you do one thing well, they keep asking you to do the same thing.
Yeah, it's a real problem.
That's just how it is.
Exactly,
right?
exactly. Yeah. So
they're like, you do this really well. Could you do a lot more of it?
Yeah, that's exactly what it was. So anyway, that's actually how I got into VR originally. Was we were looking at the next medium, the next more immersive way to, at the time, for the company I was working for, give people the experience as though they were running outdoors. And so we started playing around with VR. It's terrible for fitness. I mean, you'll get nauseated, right? But the VR was compelling enough. I completely shifted my career and said, this is the right place for experimenting with optics and cameras and really cool stuff.
Yeah. Even that relatively immersive sort of fitness video technology that was, very novel at the time, very new at the time. Isn't this amazing? The technology curve is like things that were like very hard to do and complex 10 years ago. Like we totally take it for granted.
Yeah, and it's a little dangerous if you're trying to build that technology because it's like you're running on a treadmill. I mean, when we started doing the fitness video stuff, we built our own hardware stabilized camera platforms, and now you can buy them for like $20 on Amazon. That's right. Amazing. So you gotta. That's actually why, honestly, we kind of aimed really far into the future for Visby. Is like we didn't want to build something that was going to be commoditized in a year or two. Mm-hmm. We really wanted to do something that was hadn't been done anywhere, and kind of build a foundation and build a product around it.
The opposite extreme of that was the story you just told me in the hall about Litro.
Yeah, that's true. You can't be too early. Yeah.
From like public reveal to the Computer History Museum in 18 months.
I think that was the number. Yeah.
Litro's the story.
Yeah, it's pretty interesting. I mean, they're an interesting company, and honestly, I'm doing what I'm doing in part because of Litro. Sure. I consulted for them very briefly in like 2008 or 2009, just as like a camera geek. Hey, what do you want to use this technology for? And so that got me interested in light fields, and I started collecting research around light fields from then on. Meanwhile, Litro kind of had this very large kind of growth and decline. They raised a ton of money, spent a ton of money, solved some very hard problems, but at times it was solving it by saturating it with money. And of course, now the things they were trying to do are much easier to do. For example, the price of computing, the availability of certain kinds of AI, like a lot of the stuff they had to do incrementally, step by step, by throwing money and engineers at the problem are now considerably easier.
Yeah, a lot of it is in the processing these days too, right? It's not just the lens, it's it's the processing. And I'm kind of a tech geek, like on the mobile side and things like that. It's just partly because of our work with Google, I'm like tracking these ecosystems. and what these different phones do with different cameras, right? Like the quality of the shot in the camera phone, and I think the Pixel 3 got a lot of credit for doing with one lens what a lot of other manufacturers try to do with multiple lenses, and it was purely due to the processing. Like their just processing was superior, right? Like to me, that's like a pedestrian example of what processing has done in the realm of like just mobile photography, which is the way that most people experience photography.
That's actually a hyper-relevant example. I think we're long past the point where a pixel on your phone is a pixel on the image later, right? There's so many chains of software in between that. And on the mobile side in particular, I think we're actually about to see a massive shift in the span of a few months. We have a pretty good authority that the next cameras that are coming out, both from Apple and the Android ecosystem, are going to have really good depth sensors on them. And I think that's going to really change where the algorithms play and what they do. In the short term, it's going to mean people are going to be using a lot more compute for their imaging.
Is it time of flight sensor?
That's what I heard. So again, this is just what I hear through the grapevine. But yeah, something like that.
I'm starting to see those come up on mobile, like time of flight camera. The certain things. It's super interesting for me. Again, just from a consumer standpoint, it was possible to put in the hands of the average consumer at scale. And so the technology, the light field, like can you just start from there? Because like, what is a light field? It's not something we hear about.
That's fair. That's that. Probably the average listener has never even heard of that.
Right. What is a light field?
Yeah. So a light field is really just a way of describing all the light in a space, right? So if you think of a traditional photograph, what you're really doing is you're building an image out of the light that happens to fall just on that camera lens in that one spot. If you think of the scope of all possible photos you could take, that would be sampling all of the light across a large area. That's effectively a light field. And so what we do at Visby and what other companies who've played around in light fields like Lytro have done is try to find ways to understand that entire field of light, all of light in an area. And it lets you do lots of very, very interesting things. But it's a hard problem. There's no practical way to actually capture all of the light. Physically, you cannot overlap cameras enough to capture every single light ray. If you could, you'd still be looking at somewhere from petabytes to even exabytes per photo. Because if you can imagine a very, very high resolution camera.
The storage part.
Yeah, exactly.
Just the storage part.
Just storage alone.
Petabytes. But the capturing part, this is one of your early prototypes, right? Like even the capturing part is hard, let alone the storage part.
Well, we're throwing out like 99.99999% of the light here because only light that passes through the very center of the aperture is actually contributing to any images. So we're already massively undersampling it. And even at that, the data rates are quite high. So the arrays we've been using lately compress on the fly. This is years old, so very much. That's why it sits in the conference room.
It's just a piece of art.
Yeah, exactly. It's a conversation piece, right? It's our coffee table, object of art. There are current arrays, even though they compress on the fly, we're still talking gigabytes per second, which is tractable. That's not bad. But when you take gigabytes per second and you shoot about a part of an hour, and then to process it into a light field, you have to uncompress it. So when we're actually doing the stuff up in the cloud, the footprint gets quite large.
Right. So. And do you think some of the work that you're able to do now is directly due to the scale and processing power of cloud?
Absolutely. So, again,
softball question.
Yes. Right. Compute's a big deal. If these light fields are, many, many gigabytes, terabytes uncompressed, you have to be able to throw a lot of compute at them to make sense of them. The very first light field we encoded, we actually borrowed, an on-prem cluster that a friend of mine had built. And I think it was 100 computers, each with 8 cores, ran for an entire 3-day weekend. And we got one frame, and it was very low resolution.
You're kidding me.
No. We sat around and we're like, are we ever going to be able to do video? This is an unbelievable amount of compute. Now the algorithms have gotten better.
That's a good perspective. Just for people to understand.
And two things have happened. Compute's gotten cheaper. This was like late 2015, early 2016, I think. So compute's gotten significantly cheaper and faster. The algorithms have improved a lot, right? Those are very, very early algorithms. And the two really have gotten to the point where computing is still the bottleneck for us. People ask about real-time, real-time streaming, and we have a long and complicated answer to that. But at the end of the day, it still requires a ton of computing to generate a holographic light field.
So before we dig into that a little further, because I know that there's certain things you're discovering that's unique about what Google Cloud can do in your realm, but digging into the business a little further is, and because I think these are the really interesting stories, right? I love doing this. It's relatively new, but coming and meeting with customers who are doing groundbreaking work. Can you tell us more about like the business model? Who's the customer? I know it's very early, but a lot of the magic happens in places like this,
Yeah.
at times like this. So can you tell us about what is the application of the technology?
Right.
And
So
what's the vision?
yeah, there's a multi-part answer to that, honestly, because where's the market today versus where is it going? Very, very different questions. In the short term, the main application of a holographic light field is to serve really high-end cinematic content for VR and AR. So those are the early customers we have right now.
Right.
Talking to big studios, talking to high-end VR and AR content producers, people for whom the quality of the image is really important, so that the lift around compute and cost is not as much of an issue. But long term, I think it's just obvious that we're not going to be looking at flat screens much longer, right? What's interesting about a VR headset to me is not just you can put it on and it immerses you in a world. It's that this is a holographic display. And there's early phones that are starting to nibble at it too, but your phones, your TVs, and eventually your glasses are all going to be holographic displays.
Totally.
Right? So at that point, what's it for? What are light fields for? It is what video does today. So anywhere there's video today, you're going to have something that's more holographic in the future.
Yeah, look, this is not a sustainable form factor.
No.
Honestly, how many more years of this can we have?
I don't know. My neck's already sore. So
It's not only that, but it's it hasn't really evolved if you think about it, right? There's bigger screens and more pixels, whatever, but it has to eventually become an immersive part of our experience so that we're not doing this
Right.
all the time. And I think, if you look at certain, films that are projecting to the future, they do imagine this world where it becomes part of the experience, that it's not like some thing that we carry in our pocket that we look at.
yeah, a lot of those are dystopian films I've found.
That's true. Most of the future.
That's where we're headed.
Yeah, hopefully not.
Yeah.
But they do expose Back to the Future. That wasn't too distant.
Oh, that's fair. That's fair. That's a fun
Marty
one.
McFly's life wasn't great, but
Yeah.
otherwise. But I remember the scene in that movie when there's a shark. It's an advertising.
Right,
The
yeah.
shark comes and
Totally.
But that's a hologram, right?
Yeah, so we are talking to a lot of companies that are working on the display part of that right now. So they're almost all very quiet startups, right? And hardware takes a long time, so it's not like you're going to see it next year. But there are companies that are building basically the replacement for the TV that's fundamentally holographic. And there are probably a dozen companies or so out there doing it. There's some really neat stuff we've seen behind closed doors.
So you need those ecosystems to evolve in parallel, right?
Yeah, and they will. I think
Because you need the displays, but
Right.
you need your technology
yeah, well the nice thing about
to create the content to begin with.
Yes. That's why I think VR is really important, is that it is, though small, it is a market where you can start, content creators can start understanding the technology, can start using it, applying it to VR, and then as phones and TVs and so on start to have this added capability where they can add depth or multi-perspective, then the learning from VR and AR will start to apply there as well.
Yeah, I really enjoyed seeing some of the demos, and it is definitely a different kind of image.
Yeah.
And, the extent that I think any of us have been exposed to AR, VR, there's gaming engines, you said, that do this.
Right.
But what's the fundamental problem with gaming engines vis-a-vis what you're trying to do?
I mean, the main problem is just they don't look very good. I mean, game engines are incredible at delivering you an interactive experience, calculating what you're going to see in the span of milliseconds and drawing a frame around that. But they do it with a lot of shortcuts and tricks and underlying data representations that are not real. They're just very convenient, right? So polygons and so on. As a filmmaker, if you go try to use those tools, you're fighting against those shortcuts all the time. The fidelity is just not very high. So to date, the best use of that technology I've seen, really, the filmmaker spends a lot of time working around those weaknesses, right? They hide the flaws. They use clever lighting so you don't see kind of the faces don't look very good. All the characters are wearing ponytails because hair doesn't look very good. And so what we've tried to do is to take kind of the way traditional 2D filmmaking works and simply make it holographic. And so that's the major difference. Is on set it should behave like a camera, and then when you're editing it and displaying it, it should behave like traditional film or video, where what you see in the camera is what you get out the other side.
But in order to accomplish that, you have to create technology that didn't exist, including the codecs, kind of in the way I understand it, again as a pedestrian. You have to invent a new codec.
Yeah, it's a lot of work.
Right?
Yeah, absolutely.
From the ground up.
From the ground up. That's functionally what our team has done. Different ways of representing holographic data. So it's not just arrays of pixels, and it's not polygons. It's something that's a little bit more fundamentally looking at light as the fundamental data source, and then ways to manipulate that and optimize it and so on. And the net result is it does look photographic or cinematic, right? I think because it comes out of that kind of a signal processing tradition rather than a computer vision tradition. I mean, there's lots of shared DNA, but in practice, we treat this as a problem where we're trying to record a very large data signal we care about, or at least sample it, and then try to recreate that as faithfully as possible, which is very different from what game engines try to do.
So, because you can't capture all the light, you basically have to the processing has to fill in the blanks.
Yeah, there's two major sinks for processing in this process. After capture right now, we have to send all the data up into the cloud, and there's a ton of compute that goes into creating the file itself. And then the smaller piece of compute is once you have that file or stream, the client has to decode it on the fly because we don't kind of have all the pixels in that file format. What we really have is a way for the client device to interpolate the pixels correctly.
It's like instructions.
Yeah, exactly. It's similar. I mean, you could think of it a little bit like a 2D codec in that you don't actually have data for each pixel. What you have is a series of functions that when the decompressor runs is able to kind of fill in every single pixel you want to see. The problem is with a VR headset, you don't know what pixels you want to see, right? The person could be standing in any position, looking at any angle. So you have to defer a lot more. You can't sort of commit ahead of time to knowing what that decoded output is going to look like. But functionally, it's similar to video encoder and decoder.
I mean, this is fascinating.
Yeah, it's cool stuff. It's been a lot of fun.
So you didn't start on Google Cloud.
We did not. That's true. We started on Mike's garage.
Yeah. But so what are the limitations you ran into that kind of caused you and your team to look at GCP and Google, and why, and then what are we hoping to achieve on this platform that is uniquely differentiated in terms of the value and performance or whatever else relative to the alternatives?
There's a number of points, and I apologize for not having these bulleted out, but it's pretty straightforward. There's speed, there's capacity, there's throughput, there's price, and then there's some additional capabilities that we get with GCP that we didn't have elsewhere. We were limited in the number of frames we could process at one time on our previous cloud provider, just because we were locked out to the sheer number of cores they wanted to let us spin up at any one time.
That sounds like it's hard to max out on any public cloud. But that's amazing.
Well, and it we probably could have gone through some hoops and opened some more stuff up. Our usage is very spiky, right? Because we don't just have lots of footage constantly flowing over our network. We've been in R&D, we're a seed stage company, so we do a test shoot, and we'd plan to chew on that data for the next 3 months. Well, all that processing kind of goes in right up front. So we come back from a shoot, and after being totally idle on cloud, all of a sudden we want to spin up as many thousands of GPU instances as we can. And so we would hit a ceiling on that pretty regularly.
And with Google, you won't. That's
Exactly. Yeah. And there's, we're also very interested in things like preemptible cores because for a lot of our projects, we don't actually have a short turnaround window, right? If it's going to sit for even a week, no one really cares because we're just putting all the data up there and processing it ahead of time so we can look at it later.
So if the machines get shut down, whatever.
Exactly.
But the cost is so much more favorable. So
that's huge for us. That's huge. And to be fair, when we look at pricing out our service offering, one of the two biggest costs is the compute. That is a huge part of how accessible our tech becomes, is how we can control that cost so we can bring our price down over time. So cost is, strangely enough, we're burning enough as a small company that's actually a major consideration for us.
I mean, this is a great and unique use case and story. And again, the objective is to bring these stories out into the marketplace and ecosystem so that others are inspired to do things that they feel like are impossible. And my hypothesis, and the reason that we're in this business and we're so excited about this business is nobody really adopts the Google Cloud platform unless they're really trying to do something transformational. Nobody's like, well, I was doing the same thing here in this data center. I just want to move it, to some other cloud.
Right.
Totally, this commoditized vision of what that is, with very, I think, limited imagination with regards to the value of doing that. It's like I'm going to do it exactly the same way on Google. Like nobody ever says that. Right. So I love these stories, and I think there's a consistency. Is the more customers we talk to at different stages of their life cycle, I mean, this is the promise, of this tech, and I think what makes Google unique. And so, we hope that we can push the technology, like with our engineers, your engineers, and really figure out what those upper limits may be if they exist at all. Like, this is really exciting. Yeah, well, we like to be, we do push things to the limit quite a bit. I mean, that's sort of the premise of what we're doing. You guys must see an incredible array of strange
technologies coming through your offices.
Yeah, especially in the Bay Area.
Yeah.
I think we're fortunate to be ourselves, headquartered in the West Coast. Because as I visit our other, now 7 offices, they're in different levels of maturity in the markets. And I think the West Coast, especially Bay Area, San Francisco, is uniquely positioned to push the envelope. But then, so we're in the tip of the spear. We're like at the tip of the spear.
Right.
So we're doing a lot of learning, with Google, with our customers.
Right.
Not only in I think the engagement model of like how do clients like Visby need to be supported and serviced and sold to and work with, and then what are the technical things that they're going to run into, and then we take it into the machine and we create these playbooks that we kind of take nationally, and I think the whole market benefits from these.
I can see that, yeah, because I can tell you that I think we're only unusual in that we're early. I think there's going to be a lot of companies that are touching significant amounts of imaging data, and their compute needs are going to go up dramatically. And the kind of compute they're doing is already changing, right? So I haven't touched on it yet, but there's significant pieces of AI that go into what we're building. And of course, things like TPUs are of significant interest to us, right?
Yeah.
So I think we're going to see imaging in particular start to consume a lot more of those resources. And you see it in trivial ways already, right? With the filters and the AR lenses and so on that are going on with Facebook and Snapchat. It's going to be like that, but more so.
Yeah. No, and we're headquartered in LA, obviously. Only about half of our employees now are LA based. We've really spread out quite deliberately in the last couple of years, but LA is still our home. We've been there, been around for 19 years, and so we've seen just the media entertainment vertical in general, with Google opening an LA data center, quite again purposefully, and I think maybe Jungle Book might have been the first movie that was rendered completely on GCP. And Sony ImageWorks, who does work not only just for Sony but for a lot of the major studios, I think they publicly have created some open source rendering capability on Google Cloud. So I think this is kind of maybe the beginning of what public cloud can do, even in non light field, non holographic applications. There's been a lot of heavy processing with regards to just graphics of all kinds in the movies. In media entertainment for a long time, but I think we're still in the very beginning of I think what's possible in M&E now that the power of Google Cloud is there to kind of support it.
Definitely.
And democratize access to this kind of technology.
Well, I think there's 2 secular trends there that are feeding in. One is you're seeing these technologies that are very compute intensive migrating down from the really big budget films into just basically everywhere. You now have like sketch comedy shows that are doing like high-end VFX, right? That was like, would have required an army of animators 5-10 years ago. Now it's just going to be a whole lot of compute and some pretty straightforward tools. So that's, just more people are going to be consuming more of the compute for sure. The other trend, which is a little slower, but I think is turning the tide a bit, is the studios used to be really, really hesitant to take anything to the cloud. There's security, right? So they still have big on-prem installations, but if you listen to the technologists that are down there, the tide is turning, and I think they're going to start to see more and more studio content, moving into the cloud.
So the Sony hack that was so
that comes up pretty regularly.
Well, it was very kind of close, intimate to us, not only because it's LA based, but I remember distinctly we'd taken like the email collaboration platform for Sony ImageWorks standalone to Google, and then the rest of Sony was running on premise. So when that whole thing went down, and it was epic and painful and massive. A lot of attention was I think rightfully so refocused on security and process. Sony ImageWorks was the only part of the organization completely unharmed. Right. So I think the paradigm in people's thinking is also starting to shift, and we've been doing this for a long time. The selling that we were doing 10 years ago was just convincing people that was as secure. Now I think people can understand if it's done right. If you do sort of the IAM correctly and everything else, from a network security standpoint, you can't do it more securely than Google can. Right. If you just configure it right.
Yeah, even if you're a major Hollywood studio like Sony Pictures, right? As particularly against a state actor, right? Like your home-rolled system, as good as it may be, is not going to be as good as Google's, and it's not going to be secure enough.
Yeah.
Yeah, unfortunately, the Sony hack, I think the wrong lessons were drawn from that at first, right? And people got even more scared, and I think that may have slowed some of the conversations down around cloud, but I think people are understanding it better now.
People always tend to overreact.
Yeah.
But I'm really excited. I think M&E still relatively untapped in the way that the public cloud is being consumed. I love what you guys are doing in this because A, it's very intensive.
Yep.
Google's in a unique position to, I think, help you guys break new ground. And it's also, again, will move the industry forward, hopefully, and us and Google can just play a small role in that. But
Not so small.
We'll see. Hopefully,
it's enabling.
As big as possible, right?
Yeah.
But it's anything on the tip of the spear like this is super exciting. But to the extent that you're able to foreshadow, where do you think you guys will be in 6 months, 18 months from now? Like, what are your, to the extent that you can share? Like, I don't
sound like an investor now, Tony.
No. I'm not asking for projections.
Six months, honestly, I think we're going to be running some really interesting high-end productions with some big studios.
Really?
Not publicly. Like, I think those will be in production within 6 months. Trying to get decision makers at these studios to understand light fields and get their feet wet a little bit. So that's the arc we're on there.
That means you'll be coming to LA a lot.
We're down in LA near constantly.
Okay, then we should definitely stop by my
Absolutely,
office.
happily.
You got to reciprocate. You know?
Oh, totally. I'll come by.
You
Yeah, you got to show me where the good brew pubs are. You know,
all that.
almost all of our clients and customers are down in LA. Our production partners are down in LA. So we are wearing our way back and forth on Southwest pretty regularly.
Good.
So 6 months, that's going to be going on. We're going to be pretty busy with like client projects, basically. 18 months. Without sharing too much, I think we're going to bring out another interesting kind of product line. We should probably maybe do a catch-up session at that point because I'll be able to talk more about it. But we're looking at ways to take our technology and apply it to other verticals beyond M&E. And that'll be a very interesting move for us. But I can't talk in too much detail about it except to say that it would be able to hit scale really quickly in a way that, VR is interesting. I think that it's not going to hit massive worldwide scale on the course of a couple of quarters, but other applications of our tech might.
What I love about this business model, by the way, and the way that we engage with our customers, it actually, the economics force us to be, even if we weren't like oriented like this culturally, it actually forces us to be vested in your success. Because the better you do, and the more successful we make you on Google Cloud, the more you'll consume.
Totally.
Right? Like the incentives are completely aligned.
Absolutely.
This is not the old world where you're going to pre-purchase a bunch of tech from some vendor who doesn't care if it ever gets deployed, right? Because you already paid.
Yep.
I just love the way that this drives, I think, things that were innate in us as a company from day one. But this new model is just a beautiful thing. We're literally vested in your success.
It's fantastic. Well, I hope I make you successful, Tony.
Well, no, from that standpoint, we hope we play, again, a small part in your success. And I think these relationships are really important. And we just wish you, continued success in what you're doing. And we're here to support you in any way you see fit. And I won't ask you to project any further than 18 months. Because
that's easy though, because no one holds me to that. I can go 5-10 years in the future.
I can't even do that in my own business. So I know that it'll be a lot of guessing at that point. But we're really excited for you guys.
Well, thank you very much.
And thank you for joining Cloud and Clear.
Of course, it's been a pleasure. Thanks so much, Tony.
Thank you.
Thank you for listening to Cloud and Clear. Check the show notes for links to this week's topics. And don't forget to connect with us on Twitter @CloudandClear and our website, sada.com. Be sure to rate and review the show on your favorite podcast app.